Now, welcome back to quantum mechanics. We will today discuss some mathematical tools of quantum mechanics. So, operator algebra or mathematical tools. Of quantum mechanics. Okay, I already told you every quantum system we have a wave function. For a quantum system, if we consider a quantum system, say for an 1D box, it is associated with a wave function. Wave function represent a quantum system. I can say quantum system. A quantum system is usually represented using a wave function. And there are many physical observables in the system. And for every physical observable, there exists an operator. For every physical observable, there exists an operator. Operator is associated with every physical observable. In position basis, we have seen many operators like position operator, momentum operator, right? So if you want to measure position, you have position operator. If you want to measure momentum, you have momentum operator. In position basis is IH cross dou by dou x. If you want to measure energy, you have to take or operate with the IH cross dou by dou t, and so on. Okay. So in this session, we will deal with new algebra called commutator algebra. This is very important and special operators in quantum mechanics. Commutator algebra. Okay. For two operators, operator A and for operator B, the commutator commutator of AB denoted by commutator of A with B, and it is defined as commutator of A with B is defined as AB minus B. This is a definition, AB minus B. Okay. So this is a definition of commutator AB. If A commute with B, suppose, then commutator AB equal to 0, implies AB minus BA, all are operators. Okay, so try to put the cap always. You get AB minus BA. Keep in mind, these operators are actually matrices. Later on, we will see these operators are nothing but matrices, Hermitian adjoint, Hermitian matrices. So if two matrices commute, usually they don't commute. If they commute, which means their commutator is 0. Okay. There is also a physics behind this commutator. If commutator of two operators 0 means they can simultaneously observable. The physical meaning is nothing. If commutator AB equal to 0, that implies A and B can be simultaneously measurable. They can be measured simultaneously. That is the meaning of it. Okay. If commutator of AB equal to 0, this is a meaning. They can simultaneously be measured. Okay. Now, next concept is anti-commutator. Anti-commutator. It is denoted by anti-commutator of A and B, curly brackets. This is by definition AB plus BA. This is the definition of anti-commutator. Okay. If anti-commutator of AB is equal to 0, then this is simply AB plus BA. Okay. That means AB equal to minus BA. Then it means they will anti-commute. Now we look into some important equations, important results in commutator algebra. Important results. One is commutator of x with the px equal to IH cross. Let me prove it for you. X px psi equal to, what is x px? X px minus pxx psi. But px is nothing but minus IH cross dou by dou x. So x minus IH cross dou by dou x minus IH cross dou by dou x. Here I have psi, I have x psi. So this is nothing but minus IH cross, I am okay, let me take it minus IH cross x dou psi by dou x. Here minus this become plus IH cross. So you have the product rule, you have to apply. So first dou psi by dou x, the derivative of x into dou psi by dou x. Then the next one is IH cross, derivative of x is simply 1. Therefore IH cross psi. Right? So if you look, the first two terms will be cancel each other and you are left with the IH cross psi. If you compare on left and right hand side, x px psi equal to IH cross psi, that simply implies x px equal to IH cross. Okay, this is the standard result. X and its canonical momentum, position and its canonical momentum is not commute. It is not 0. It means they not commute, which means x and px cannot be measured simultaneously. They are not simultaneously measurable. Okay. Now let me introduce the other results also. Also, I could say also we have x px is equal to IH cross. Similarly, y py equal to IH cross and ZPZ equal to IH cross. All other combinations are 0. All other combinations are 0. Okay, which means if you take x with the py equal to x with the pz, these guys are 0. Y with the px equal to y with the pz, this is 0. And y with the, I'm sorry, z with the px and z with the py, they are also 0. Okay, that's it. Now the properties. Okay, let me take one more thing. If order is reversed, or let me take it, if AB, commutator of AB equal to minus of commutator of BA. That means if the order is reversed, there will be a negative sign. Therefore, we have PXX equal to PYY equal to PZZ. These guys equal to minus IH cross. Okay, if order is reversed, there will be a negative sign. That is one of the property. Once we will deal with the property, we will introduce it again. Okay, so properties. Commutators. Commutators in the property. One, it is anti-symmetric. Anti-symmetric. Anti-symmetric എന്ന് പറയുമ്പോൾ commutator of A with B, that is commutator of AB equal to minus commutator of B with A. Commutator of AB equal to minus commutator of BA. The second one is linearity. Linearity means commutator of A with the B plus C plus D plus etc. etc. If you have something like this, you have to split commutator of A with B plus commutator of A with C plus commutator of A with D plus etc. We can split it. Okay, this is called linearity. And you have to keep in mind every operator commute with itself. Okay, every operator commute with itself. Also, every operator commute with a constant term. K is constant. Every operator commute with itself, and every operator commute with a constant. Then every operator commute with a function of its own, where f of A is function of A. Every operator commute with its own function. Okay. Now, for A, B, C, the product terms comes, then keep in mind, whatever be the first term, that have to put it first. B, commutator of other two. Okay. Plus commutator of AB, product second നിൽക്കുന്ന ആരാണോ അതിനെ കമ്മ്യൂട്ടേറ്ററിന്റെ റൈറ്റിലെ ഇടാവും. ഓക്കെ, ലെഫ്റ്റ് നിൽക്കുന്ന ആള്, പ്രോഡക്റ്റിൽ ലെഫ്റ്റ് നിൽക്കുന്ന ആള് കമ്മ്യൂട്ടേറ്ററിന്റെ ഫ്രണ്ടിൽ ഇടണം, റൈറ്റ് നിൽക്കുന്ന ആള് കമ്മ്യൂട്ടേറ്ററിന്റെ റൈറ്റ് ഇടണം. The operator which is on the first should put left, and which is on the right hand side put on the right side of the commutator. You should follow this. Okay, suppose you have x px y, something like this. Then you should put px, your x with y, plus x px with y. You should write like this. Okay. Suppose, what about this? X py z. How do you write? First py, x with z, plus commutator of x py with z. Right? Yes. Suppose you have XYZ or XYPZ, something like this. How do you write? First, ഇതാണ് product അല്ലേ? XYPZ plus XPZ Y, because Y is the second term in the product. So you have to put here. X is the first term, you have to put here. Okay. So that is all about commutator of a quantity with its own guide. Now, next property is fifth one, commutator of AB dagger. Transpose of complex conjugate is called a dagger. Okay, it's called a Hermitian in if we study matrix. So AB dagger equal to B dagger A dagger. AB dagger commutator equal to B dagger A dagger. Okay. Next one is commutator of A, commutator of B with C plus commutator of B with the commutator of C with the A plus ABC BCA C, commutator of C, commutator of A with the B. Okay, ABC BCA CAB, this should be 0. Okay, this guy is called a Jacobi identity. You can check it out. Okay. And next one, constant terms can be pulled out. That is, if A, you have a constant with B, then you can write simply, you can pull out that constant. You can then commutator A with the commutator. If there is constant term, then we can pull it out. Okay. Now, next identity. If we have a function f of A and we want to analyze its commutator with a B, then a function of A commutator with the B is simply commutator AB into differentiation of that function with respect to the variable. If you have something like this, A commutator, A commutator of A with some function of B, something like this, then you will get commutator AB with dou F by dou B. AB with the dou F by dou. Okay, this is an identity. Take the commutator with AB, then differentiate that function. Okay, let me execute some problems based on these ideas first. So the first question will be, let A equal to x plus y, x plus py, and your B equal to y plus pz. Okay. Then what is commutator of AB? So let me check. A commutator B is nothing but x plus py commutator y plus pz. Now we have to apply the linear property of commutator. So that is nothing but first you have x with the other guys, x with the y plus x with the pz plus py with the py, sorry, py with the y plus py with the pz. Okay, so these are simply the position operators. So they will commute. Plus x with the pz also 0. Y with the py is minus ih cross. Py with the pz is 0. So our answer will be minus ih cross. Okay, so keep in mind xi with xj is 0. Similarly, pi with the pj equal to 0. Two position operator and a momentum operator will come. Okay, ij's are just one whether two, no problem. Okay, there are two positions, that's it. Now next one, second question. Suppose your a equal to x plus iy and b equal to px plus ipy. The commutator of ab is, commutator of ab as per definition, x plus iy commutator with px plus ipy. I told you this is, you have to apply the linear. So x px plus I is the constant, pull it out, x py plus I is constant, y px, I with I is negative, y py. Now apply the identity, x px is ih cross, I into x py is 0, plus y px is 0, y py is ih cross, therefore minus ih cross, and totally our answer will be 0. Okay, now x square px, which is the form, actually this is of the form f of a b. Okay, before introducing this formula, let me try in a different way. X px. Okay, so this is the first one, this is second one, therefore x px plus x px x. So x px is ih cross plus ih cross x. This is 2ih cross x. Right. But using this equation, we can solve it in a single step. F of a with b, I told you this is commutator of ab with the dou f by dou a. Now you have x square with the px. Your a is x, therefore x px into d by dx of your function x square. That is, x px is ih cross, derivative of x square is 2x, therefore 2ih cross x. This is your answer. Okay. So applying that identity, we can solve it in a simple step if you are strong enough in mathematics. Okay. What about this? What about this guy? Let x cube px. So this is nothing but commutator of x with the px into dou by dou x of x cube, right? So this is nothing but ih cross into 3x square. This is the answer. What about this? X px square. Here a px is b, therefore x px into dou by dou px of px square. ഏതാണോ വേരിയബിൾ അത് വെച്ചുകൊണ്ട് ഡിഫറൻഷിയേറ്റ് ചെയ്യാം. Okay, so you will get ih cross 2px. Okay, so next question. Suppose you have x px power n. Then what happened? Now x px into dou by dou px px power n. X px is nothing but ih cross. Dou by dou of px power n is n px power n minus 1. Okay. What about this? X power n px, same. X px, now you have dou by dou x, x power n. This is nothing but ih cross. This is ih cross n x power n minus 1. This is a difference. Okay. Sometimes other functions may come. Suppose you have e raised to x px. What happened? Now this is your f of a. This is your p. By equation, f of a with b is simply commutator of a with b dou f by dou a. That's it. So your function is e raised to x, but your a is identified to be x. So x with px into dou by dou x of e raised to x. That's it. That is ih cross e raised to x. Now you have e raised to x square px. That will be, you have your x px dou by dou x of e raised to x square. X px commutator is ih cross. Derivative of e raised to x square is e raised to x square into 2x. So this is the answer. What if you have something 1 by x px? Your function is a is x and b is px. Now dou by dou x of 1 by x. That is, here you get ih cross. Dou by dou x of 1 by x is minus 1 by x square. This is your answer. What about this? You have x with e raised to px. This is also simple. Commutator of x with px into dou by dou px. Why? Because f of b function px in the terms now. So e raised to px. So this is ih cross. Derivative of this will be e raised to px only, no other change. Suppose you have something like this, x 1 by px. So x px is ih cross. I am writing it in a single step. X px will commutator will be ih cross. Derivative of 1 by px will be minus 1 by px square. Okay. So what about this? We have x ln px. That will be ih cross. X px will be ih cross dou by dou x of, dou by dou px of log px. Log x in the derivative 1 by x. Therefore, you will get ih cross by 1 by, instead of x, you have px. Okay. Now, suppose you have next a question, which is x square px square. Here, you have to split any one of it, x px square, or you can put x square px. That's up to you. Now apply the equation x px square plus x px square x. So you have x into x px square will be ih cross 2px, right? Plus here also ih cross 2px. into x. So you have IH cross 2IH cross xpx plus pxx. Since they are operators, you cannot write 2 times xpx. The order is very important. So answer should be this. You should not write 2 times xpx. That is not true. അതുകൊണ്ടാണ് ഇവിടുത്തെ ഓർഡർ വളരെ ഇമ്പോർട്ടൻ്റ് ആണെന്ന് പറഞ്ഞു. ഓക്കെ, നിങ്ങളിപ്പോൾ ഇതിനെ സ്പ്ലിറ്റ് ചെയ്യുന്നത് എക്സ് സ്ക്വയർ പി എക്സ് എന്നായാലും ഇത് തന്നെ കിട്ടും. ഓക്കെ, അതൊന്ന് ചെയ്ത് നോക്കാം കേട്ടോ, ചെയ്ത് നോക്കണം. Now next question, you have xpy minus pxy ഇങ്ങനെ വന്നു. So as per our equation, now you should be very careful because you have to apply the linearity here, because A, B, C, D, something like that is coming, right? So first you have x, I'm sorry, this is our first function. Therefore x py with pxy plus x px with y py. Okay, ഇതാണ് ഫസ്റ്റ്, ഇതാണ് സെക്കൻഡ്. Therefore commutator എഴുതുമ്പോൾ when this guy together x should be first, when this guy together py should be last. Now this is x into again നിങ്ങൾ നോക്കുക, അവിടെ എന്ത് ചെയ്യണം, നിങ്ങൾ സ്പ്ലിറ്റ് ചെയ്യണം. കുറച്ച് ലോജിക്കലി ചിന്തിച്ചു കഴിഞ്ഞാൽ ഓക്കെ, ഈ ക്വസ്റ്റ്യൻ ഞാൻ ചെയ്യാം, എന്നിട്ട് പറഞ്ഞുതരാം എങ്ങനെയാണ്. ഇവിടെ വീണ്ടും you have to take pxy, ഇതൊരു പ്രോഡക്റ്റ് അല്ലേ, therefore px should become first, py with y plus py px with y plus second term എഴുതുമ്പോൾ you have x px, so px into commutator of x with y plus commutator of x with px into y, because it is last. First term px ആണ്, അതുകൊണ്ട് ഇവിടെ വന്നു. ലാസ്റ്റ് ടേം y ആണ്, ഇവിടെ വന്നു. This is multiplied with the py. Now listen, x into py is minus ih cross, therefore px into minus ih cross. Px py is simply 0 plus xy is 0, x ps is ih cross y py. So I am left with ih cross can be taken out. So ih cross y py minus x px, y py minus x px, that will be your answer. ഇത് നിങ്ങൾ ഇത്രയും കോംപ്ലിക്കേറ്റഡ് ആക്കാണ്ട് നിങ്ങൾക്ക് ഒറ്റ അടിയിൽ ചെയ്യാൻ പറ്റണം. എങ്ങനെയെന്ന് വെച്ചാൽ ഇതാ, നിങ്ങൾ ഇവിടുന്ന് നോക്കുമ്പോൾ ഇത് ആദ്യത്തെ സ്റ്റെപ്പ് എഴുതി നോക്കുമ്പോൾ ഇവിടെ പ്രോഡക്റ്റുകൾ, അതായത് കമ്മ്യൂട്ടേറ്ററുകൾ വരുന്നത് പി എക്സ് പി വൈ ആണ്. അപ്പൊ അത് എടുക്കണ്ട, പി വൈ എടുക്കണം. അപ്പൊ അതിനനുസരിച്ചിട്ടുള്ള ടേം മാത്രം കൺസിഡർ ചെയ്താണ്. എക്സ് പി എക്സ് ഐ എച്ച് ക്രോസ് ആണ്, അത് എടുക്കണം. ബാക്കി എക്സ് വൈ എല്ലാം വാനിഷ് ആവും. അപ്പോ ഒറ്റയടിക്ക് നോക്കിയിട്ട് എക്സിസ്റ്റ് ചെയ്യുന്ന ടേമുകളെ മാത്രം എന്ത് ചെയ്താൽ മതി, പിക്ക് ചെയ്താൽ മതി. ബുദ്ധിമുട്ടുള്ളവർ എല്ലാ ടേമുകളും എന്ത് ചെയ്യുക, പിക്ക് ചെയ്യുക, നോ ഇഷ്യൂ. Okay, so you have to wisely pick the terms. You need not to solve everything. So one more question I will give you. X p z py. Okay, let me pick it in a single step. Now you have x p z py plus x z py with pz. So taking the cross product will leaves you something. Therefore x ih cross z, pz will be ih cross py and p z py will be 0, plus here also you have xz will be 0, and you have remaining z into, because it is a first term, xpy, that is also 0. So second term will be 0. So answer is simply minus IH cross. PS Z is minus IH cross. XPY. This will be the answer. You should follow this. Okay. Now, commutator of differential operator. Commutator of differential operators. If you have x with dou by dou x, you will simply get minus 1. You will have dou by dou x with x. This is 1. That is dou by dou x with x is 1. You have to remember this. Derivative of x is simply 1. So keep that in mind. Okay. Questions. X dou by dou x. Let me prove this. Okay. In order to prove, what I am doing is I am just multiplying with the IH cross. Okay. Dividing with the IH cross minus IH cross. I can take the constant inside into here x dou by dou x. So this is simply minus 1 by IH cross x. I am taking this part inside, minus IH cross dou by dou x. That is minus 1 by IH cross. What is this? Minus IH cross dou by dou x is px. X px is IH cross. Therefore, minus IH cross into IH cross. IH cross cancel. You get x dou by dou x is simply minus 1. Okay. Suppose you have a function f of x dou by dou x. Then what happened? Then simply x with dou by dou x into take the derivative of the function f of x. A function and differential operator comes, do this. For example, you have something like cos x d by dx. You have to first take x with dou by dou x of cos x. X with dou by dou x is simply minus 1 into derivative of cos x is minus sin x, and our answer will be sin x. Okay. Suppose you have Hamiltonian h is equal to px square by 2m plus half kx square. Okay. You have to find your x with h and your px with h. X with h means x with px squared by 2m plus half kx squared. This is, you have to split x with px squared by 2m plus half k is a constant, therefore x with x squared. You know this term will cancel because a function with commute with itself or commute with its function. But here you can pull 1 by 2m outside. X with the px square, that will be IH cross into 2px. Therefore, answer will be IH cross upon m px. Simple. Then what about px with h? that will be px with the px square by 2m, that will be of course 0, plus px with the half kx square. This term is 0 because px with the px square is 0. Here you have half k is a constant. Px is minus ih cross and the derivative of x square is 2x. And you will have minus ih cross kx. Okay. Let a equal to p squared by 2m. Then find xa and x with xa. First, let me find xa. That is x into p squared by 2m. Okay, px squared by 2m. Okay, let me write it p squared by 2m first. P squared means px square plus py square plus pz square. So if you write 1 by 2m can be taken out, x with the px square plus py square plus pz square. But only x with the px is non-vanishing. Therefore, 1 by 2m into x with the px is ih cross into derivative of px is 2px. So you left with the ih cross px by m. Okay. Now you have to put x, xa. That is x. You have to find xa is ih cross px by m. So take the constants outside. Ih cross by m. Your x with the px is again ih cross. That is ih cross whole square by m. That is minus h cross square by m. Okay. That's it. Now, this is all about differential operator. Now, let me introduce you angular momentum operator. Angular momentum operator. Your angular momentum vector L equal to, R cross P. What is R actually equal to? X cap, y cap plus z cap. What is your P equal to? Px x cap plus py y cap plus pz cap. Then what is your L vector is equal to? Determinant of x cap, y cap, z cap. R is x, y, z, px, py, pz. This is the way you have to find your L. Cross product of two vectors is defined like this. This will be x cap into y pz minus z py minus y cap into x pz minus z px plus z cap into x py minus y px. Okay. So on rearranging, I will get L vector is equal to x cap into y pz minus z py plus y cap into, I am taking the negative out, z px minus x pz plus z cap into x py minus y px. So there is a symmetry. X, y, z, x, y, p, z, y, x, p, z, px, reverse order. Z cap, x, py minus y, px. There is a symmetry. So L is also equal to x cap Lx plus y cap Ly plus z cap Lz. This is L vector. So comparing the above two equations, you can get the components of angular momentum. That is, your Lx is simply ypz, x is ypz minus zpy, xyz, that cyclic order comes. Ly equal to, that should be zpy, right? You see, zpx minus xpz. I'm sorry, xpz. And finally, Lz, can you predict what would be? Lz should be ypz minus zpy. Oh, I'm sorry. Lz should be xpy, zxy. So xpy minus ypx. So order x to y, y to z, that order you should have keep track. Lx is ypz minus zpy. Ly is zpx minus xpz. Lz is zxy, zpy minus ypx. Okay. So now let us solve some identities. So I request you to remember these angular momentum components. No need to remember, you can simply derive it, but if you remember, you can save some time during the calculation. Okay. So try to remember, it's very simple. You can apply that symmetrical order. Okay. Now let me solve some questions for you. The first one is commutator of Lx, Ly. This is equal to commutator of what is Lx? Lx is ypz minus zpy, right? What is Ly? Ly is zpx minus xpz. Okay. So apply the condition of linearity. You should have ypz commutator with zpx plus ypz commutator with minus xpz, right? Plus here you have minus, therefore minus zpy commutator with zpx minus minus, you again get plus. You have zpy, you have xpz. Apply your logic first. So if you take the y outside, you have to commute with the zpz. That term will exist. Pz px will go off, right? And while you calculating with y and the commutator of others, yz will go and ypx is also go. So only the commutator existing here will be this term. Okay, അതായത് നിങ്ങൾ ഇതിനെ എക്സ്പാൻഡ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഇതിനെ എഴുതുകയാണെങ്കിൽ ഇങ്ങനെയല്ലേ എഴുതണേ, y pz zpx plus y zpx pz. ഇവിടെ നിങ്ങൾ നോക്കുക, ഇതിൽ ഈ ഒരു ടേം മാത്രമേ നോൺ വാനിഷിംഗ് ആയിട്ടുള്ളൂ, ബാക്കിയെല്ലാം വാനിഷിംഗ്. ഇവിടെ എല്ലാം വാനിഷിംഗ്. അപ്പോൾ നോൺ വാനിഷിംഗ് ആയിട്ടുള്ള ടേമുകളെ മാത്രം ഐഡന്റിഫൈ ചെയ്ത് ഒറ്റ സ്റ്റെപ്പിൽ എഴുതാൻ പഠിക്കുന്നു. ഓക്കെ, അല്ലെങ്കിൽ നിങ്ങൾ അതിനെ എക്സ്പാൻഡ് ചെയ്ത് എൻ്റെ ആകുമ്പോൾ ഒരുപാട് ടൈം. ഓക്കെ, so you should learn to write in a single step. So if you see, only this term will, if you take the commutator, will exist. The remaining will be y. That is simply the first term, therefore I h cross pz is therefore minus I h cross px plus here is also a minus in the constant, so take it out. Now if you look at this, yx will goes off, y pz, that will goes, pzx goes, pz goes, everything will 0. Minus here z px, y pz, everything is 0 again. Plus here zx goes off, ZPZ exist. ZPZ will exist. Therefore, you have to take it. Let me take it. I'll take it out. Take it out. You have Z. Py with those commutators will be 0. While you take Z, that will exist. Therefore, Z XPZ Py. Right. So order is important. That is why I am putting that. Once you solve this, you will get X into ZPZ is IH cross Py. So our answer will be IH cross XPY minus YPX. What is XPY minus YPX? This is LZ. Therefore, IH cross LZ. So commutator of LX, LY will be IH cross LZ. Okay. Similarly, you try every term. Okay. Let me solve it. I have LZ with LX. This is LZ will be Z. Therefore, XPY minus YPX. Commutator LX. Therefore, YPZ minus ZPY. Okay. So first we have to take that step XPY YPZ. Okay. Next minus XPY ZPY. Minus again YPX, this term with this, YPX YPZ plus YPX ZPY. Now apply your logic. When you take this X out and taking the commutator with the PY, this guy, one term will exist. Therefore, X PY Y is minus IH cross. You have PZ is there. Minus, if you take X out and take in the commutator, nothing will exist. And you take the commutator of X with the ZPY, you will get nothing. Therefore, this term is 0. Here also, first you taking commutator of PX with the PYZ, nothing will exist. If you take the commutator of Y with the YZ, YPZ, nothing will exist. Therefore, minus 0. Here, first you are taking the commutator of Px with this guy, that will be nothing. But Y with this will exist. Therefore, Y commutator ZPY with the Px, that will exist. Therefore, we have, what is this equal? This is nothing. Z IH cross X Px. Therefore, IH cross I am taking out. ZPX minus XPZ, which is LY, right? Therefore, commutator of LY LZ is equal to IH cross LY. You remember that order, Y is at Y. Oh, I'm sorry. Now we have calculated LZX, right? ZX. So, ZX IH cross LY. Now, can you predict what would be LY LZ? That should be IH cross Y Z LX. It should come. Let us check. First, what is LY? LY is ZPX minus XPZ. Commutator with LZ. That is XPY minus YPX. First term, try to write it out. If you are able to write it in a single step, you can do, but I am not that much confident. Therefore, ZPX XPY minus ZPX ypx minus z xpz xpy plus xpz ypx. Okay. So this is equal to, you have your x zpx. So taking z and taking this guy here, you will get minus ih cross. Therefore, z minus ih cross py, that will comes. If you take the z commutator of with this guy, everything will be 0. If you taking px commutator of with z with this guy, that is also 0. Same here, x commutator with this guy will be 0 and pz commutator with this will be 0. Plus here, if you commutator of x with y pz px, there will be something unknown 0. Therefore, that will be there. Your y ih cross pz. So ih cross ypz minus zpy. What is this equal to? Ypz minus zpy will be lx, right? So this is ih cross lx. That is our prediction. You see, that is our prediction. So we get the answer. So we have seen here that the angular momentum operator, the conclusions are this: lx ly equal to ih cross lz, ly lz is equal to ih cross lx, lz ly equal to ih cross zx. I'm sorry, zx x is equal to lx is equal to ih cross ly. More simply, we could write this: li lj, this will be equal to ih cross theta ijk, Levi-Civita simple lk. If it is in the same order, we will get 1. If it is in the same order, we will get plus 1. If it is in different order, we will get minus 1. If some terms repeats, we will get 0. Okay. I think we can stop here, right? Then we will, in the next session, we will discuss, or let me move further. Okay, let me move up to, let me finish this angular momentum operator. Okay. So now we are going to derive the identity from L. Okay. L with the R. L with the R type. Okay. Listen. We have to consider every single possibility, everything. Therefore, x lx equal to x. What is your lx? Y pz minus z py. Okay. So x with the px only non-vanishing. Everything will be else will be 0. So this is simply 0. So x lx is 0. What about y lx? Y lx is y pz minus z py. Okay, if you watch closely, you can see y py term is there, right? Y py term is there. That is minus y z py you have to consider. So you will get y py is minus ih cross. So minus is here. Sorry, y py is ih cross. So z ih cross. So y lx is minus ih cross z. Okay. Similarly, you can find z lx. That will be z lx is y lz minus z Ly. Of course, Z with LZ is there, that will exist. Therefore, you will have Y ZLX, LZ is IH cross. Now, you have consider X, Y, Z, these guys with the LX. Now, you can take Ly. Okay. So, X with the Ly. This is X with what is Ly? Z Px minus X Pz, that is Ly. Now observe closely, this term is non-vanishing. Therefore, Z X Px is IH cross. Okay. Now Y Ly, that is Y Ly is Z Px minus X Pz. If you see Y, Py is not there, there will be 0. And Z Ly will be Z Ly is Y Px minus, oh, I'm sorry, Ly is Z Ly is Z Px minus X Pz. If you look at closely, the term Z Pz will be there. Therefore, we have minus X is there. Z Pz will be IH cross. So IH cross minus X will be the answer. Now you have considered Ly also. Now we have to move to LZ term. Okay. First X LZ, that is X into LZ is ZX, ZXY, XPY minus YPX. This is your LZ. So X with the PX term is there, that will non-vanishing. Therefore, minus Y, X with the PX is IH cross. If you have Y with LZ, that will be Y with the LZ is XPY minus YPX. So Y with the PY will be non-vanishing. Therefore, how do you get? X into Y with the PY is IH cross. Everything else will be 0. And your Z with the LZ, that will be Z. LZ is XPY minus YPX. Here, PZ is not there. Therefore, this will be 0. Okay. Now we can conclude it. You have seen that X with the LZ, or I'm sorry, LX is 0. But this guys will exist. Y with the Ly is there, which is minus IH cross Z. Z with the LZ, I'm sorry, LX. Conclusions. X with the LX equal to 0. Y with the Ly. First, I have to consider all LX terms. Okay. Y with the LX. Minus IH cross Z. Order noka. YX. Reverse order ആണ് അതുകൊണ്ട് -1. Z LX അത് പ്ലസ് ആയിരിക്കും. നിങ്ങൾ നോക്കിക്കേ, നിങ്ങൾ പ്രൂവ് ചെയ്ത് IH ക്രോസ് Y. കണ്ടോ? X LX ആണെങ്കിൽ 0, Y LX ആണെങ്കിൽ ഏതാണോ ഇവിടെ ഇല്ലാത്ത പൊസിഷൻ കോർഡിനേറ്റ് അത് വരും. With the order you have to take. Cyclic ആണെങ്കിൽ അത് plus, not cyclic. If it will be minus. Now, the result y ly. This is 0. Now, x ly is ih cross z. X y z. Positive one. Now, z ly will be ih cross x ആയിരിക്കും. z y ആണ്. അതുകൊണ്ട് reverse order ആണ്. Therefore, minus. Then finally, you will have z lz, that is 0. You have x lz, that is ih cross y ആയിരിക്കും. But x z y is not cyclic. Next, y lz is ih cross x, y z x, cyclic ആണ്. Therefore, it's positive. Okay. So, what is the best way? If you have L angular momentum component with R, your answer will be either plus or minus ih cross, okay, missing component. That is Lx y ആണെങ്കിൽ missing component ഏതാണ്? Missing position component. Okay. Missing component from position. അങ്ങനെ എഴുതാം. ഇതാണ് കുറച്ചുകൂടെ മീനിങ്. Missing component equal to z. അത് എവിടെ നിന്ന് എടുക്കണം? പൊസിഷനിൽ നിന്ന് എടുക്കണം. Not Lz, from position. Okay. Order cyclic ആണെങ്കിൽ, that is x y z, ഈ ഓർഡർ ആണെങ്കിൽ അത് പോസിറ്റീവും അല്ലെങ്കിൽ അത് നെഗറ്റീവാണ്. x then goes to y goes to z. ഇങ്ങനെയാണ് പോകണമെങ്കിൽ അത് പോസിറ്റീവ്, തിരിച്ചു വന്നാൽ അത് നെഗറ്റീവാണ്. ഓർത്ത് വയ്ക്കുക. ഓക്കെ. Okay. I think we can discuss momentum also. Momentum kuda parnittu nirtham. The momentum vector containing the component px, py, pz. Okay. So L ന്റെ ഓരോ കമ്പോണന്റും ഇതുമായിട്ട് നിങ്ങൾ ഇപ്പൊ ചെയ്തതുപോലെ ചെയ്തു നോക്കണം. Px with Lx, that will be Px with Lx is y pz minus z py. Px x മാത്രമായിട്ട് നിൽക്കുള്ളൂ. ഇവിടെ അങ്ങനെ ഉണ്ടോ? ഇല്ല. Therefore 0. Now Py with Lx, so Py Lx is y pz minus z py. Py y excess team, therefore, which is minus ih cross y. I'm sorry, remaining term is z, pz. ബാക്കി ടേമുകളെല്ലാം നിങ്ങൾ നോക്കി നോക്കുക. That would be 0. Now you have pz lx, that will be pz. Lx is y pz minus z py. pz z at a non vanishing ആണ്. അപ്പോൾ ഈ ടേം അവിടെ എക്സിസ്റ്റ് ചെയ്യും. ഓൾറെഡി ഇവിടെ ഒരു മൈനസ് ഉണ്ട്. there is a minus. pz z is minus ih cross py, that is ih cross py. You see the order z x py. Okay. അപ്പോൾ we have considered all component of p with lx. Now px with ly, that will be px. What is ly? z px minus x pz, that is ly. So px non-vanishing component is x, so that is existing. Here is a minus. Px x will be minus ih cross into PZ, that is IH cross PZ. Then PY with LY, definitely it should be 0. PY, LY will be ZPX minus XPZ. There is no Y, therefore this should be 0. Now PZLY, it's very simple, right? PZ, ZPX minus XPZ is there. PZ is non-vanishing with the Z, but Z is existing there. Therefore, PZ is IH cross minus IH cross PX. Now we can go with the LZ. PX LZ. This is PX. What is your LZ? X L X PY minus YPX. That is your LZ. PX non-vanishing with X, that term is there, therefore minus IH cross PY. PX with the, PY with the LZ, that will be PY. LZ is XPY minus YPX. So you have this PY with Y is there. So there is already a negative. PY with Y is minus IH cross PX. So this is IH cross PX. Now the final term, PZ with the LZ, that is PZ with LZ is XPY minus YPX. So PZ, there is no Z term, therefore this is 0. Now you can write the conclusion. From the above proved result, you can write the conclusion. What is your conclusions? You have seen PX with the LX. Definitely X with X term, that should be 0. PX with the, PY with the LX. So that should be something IH cross missing term in Y, that is PZ. Order YX, not cyclic, therefore minus. Now PZ with the LX. So there will be IH cross PZL. Therefore, Z on the X on the Y will become order noka ZXY. Okay, therefore plus. Now PX with the LY, there will be IH cross XY. So PZ will be there. XYZ order lana, so positive. Now PY with LY, definitely this guy will be 0. Both are Y. Then you have PZ with LY, that should be IH cross into PZY, therefore X, PX. ZYX is not cyclic, therefore not in the proper order, therefore negative. Okay. Now you have PX LZ, IH cross XZ, therefore PYV should be there, but XZY is in the order cyclic, therefore plus. Now PY LZ, that is IH cross PX should be there, but YZ in the opposite order minus. Now PZ with the LZ, that will definitely 0. Okay. For instance, I think we can stop here and we will start discussing this problem from this session, and we will move to exponential operators in the next class. Thank you.